Consider the two cylindrical conductors A and B made up of same metals connected in series to a battery. Length and radius of B are twice that of A. So mu and mobility. Mu equals to Vd by E, J equals to sigma by E, E equals to J by sigma. So J is I by A. So mu equals to Vd sigma, J is I by A. So like mobility proportional to area. Mobility of A proportional to R square, mobility of B, this is 2R square. Cancelling R square, so this is 1 by 4. Mu A by mu B equals to 1 by 4. A wire of length 0.5 meter and cross-sectional area this much is connected to a battery of 2 volt. Maintains a current of 1.5 ampere. So the conductivity is how much? J equals to sigma into E. J is I by A, sigma, E equals to V by L. Putting the value, sigma equals to 3.75, 10 to the power 6. 10 to the 6, that is the value of conductivity. Then bit 3, temperature coefficient of resistance of nichrome is this much. In order to increase the resistance of nichrome 8.5%, temperature how much it will increase? We know that formula is RT equals to R0 whole 1 plus alpha delta T. That is the formula. So RT minus R0 equals to R0 alpha delta T. So RT minus R0 by R0 equals to alpha into delta T. So this is 8.5%. So 8.5 by 100 equals to alpha delta T. Alpha value is given. Delta T, equation 1. Putting this value over here. Alpha delta T 8.5 by 100. Delta T equals to 500 degrees centigrade. 500 degrees centigrade. Consider the contribution of the following factors 1 and 2 resistivity of the metal. Resistivity equals to M divided by E square n tau. Resistivity. As resistivity is M by E square n tau, resistivity is inversely proportional to relaxation time. Resistivity inversely proportional to 1 by N. So resistivity of the metal increases with increase in temperature. So resistivity as this decreases, relaxation time decreases, and this N is constant. So this is correct. So if steady current flows in a copper wire of non-uniform cross section, consider the following 3 physical quantities. So electric field, current density and drift speed. Non-uniform cross sectional area. So J equals to I by A, area is there, so it is not constant, it is changing. Vd equals to I by A, and area is there, so it is changing. Electric field is constant. So option A is correct.